Question number 80. The switch S here, right here in this figure, is kept closed for a long time and is then opened at t equal to 0. Find the current in this middle 10 ohm resistor at t equal to 1 millisecond. So this problem is simple, but you need to understand what is going on before the switch closed and after the switch closed, and so on and so forth. So first, let us close this switch S here and keep it closed. What is happening? From this battery, a current flows from here to this resistor and to this resistor. It keeps flowing in this loop. The current does not flow, maybe momentarily it flows here, but then the current stops here. So because of this current flow for a long time, there is this resistor, this whole loop, it creates a voltage divider of 10, and that 12 volt gets divided into 10 ohm and 10 ohm. As a result of which, there is a voltage across this capacitor. That voltage in the steady state, when the capacitor is closed, is half of this voltage, because this is 10 ohm and 10 ohm, so it gets divided by half. So the voltage across this resistor is 6 volt. Now, this 6 volt also appears across this capacitor. It may be, initially it may not be the 6 volt, but because it says that the switch is kept closed for a long time, after a long time, you will have this voltage 6 volt appearing across this capacitor. So this is what it is happening in terms of the capacitor. Current keeps flowing here, keeps flowing, and then there is a steady 6 volt charge on this. Now what we are doing is we are just removing this switch. What happens when you remove this switch? This whole circuit gets out of the picture because there is no current in this circuit. So watch this circuit here. Once you after a long time, 6 volt appears here on this capacitor, 6 volt is here, and then you remove the circuit, anything below this. So what happens after that? When you remove this voltage source, there is nothing in this circuit then that can keep this 6 volt maintaining, because the voltage source, the current continuously flowing, was maintaining this volt. Now you remove this thing. This is the circuit, the current keeps flowing. It starts flowing. The voltage here, this voltage 6 volt, it starts making a current flow in this loop. And this 6 volt will start going down till whole 6 volt becomes 0. That means this is equivalent to a problem that says a capacitor is charged to a voltage 6 and then connected to a 10 ohm resistor. What will be the current in this resistor after 1 millisecond? That is what the problem is. So now we know that this problem is now a discharging through a resistor. We can go out, and actual problem is very easy. The current I in this discharging circuit is given by I is equal to I naught e to the power minus t by RC, where I naught is the initial surge current through this circuit, which will be this voltage 6 volt divided by this resistor 10 ohm multiplied by e to the power of minus t we are required to find at 1 millisecond, divided by R is 10 ohm and capacitance is 25 microfarad. 10 to the power minus 6, 10 to the power minus 3 cancel, it goes up, becomes 10 to the power 3. 10 to the power 3 divided by 250 is 4, so it becomes e to the power minus 4. If you calculate e to the power minus 4 and multiplied by 0.6, you get 0.108 ampere.